Let's take a look at this clip of the refueling of an aeroplane. Notice how they attach a cable from this tanker and connect it to the metal body of the plane before they start fueling. Now you might be wondering why I have shown you the clip of the refueling of an aeroplane. Since electrostatics and refueling of aeroplanes, these are two completely unrelated things. Or are they? So to know that, now let me show you something else. I will need to show you the Turboelectric series once again, but this time it's a bit modern, a bit modified Turboelectric series. This is something new that you are going to see right now. For this, I looked at the net and I found this version of the Turboelectric series on Alpha Lab Inc. This Turboelectric series is modern and it is modified and it is a bit more acquainted with the industry. What I really mean to say is that they contain a list of materials that are practical, that are used in our everyday lives. So now, here they say something which is really important. They say that this table can be used to select materials, all materials that can minimize static charging. So they're actually trying to get people to know how to use the Turboelectric series to minimize static charging, to select materials that will minimize static charge. So now let us look at this table. So here I was searching for a particular thing. I was searching for something which is called aviation fuel. However, I couldn't find aviation fuel in this list, so I went for something which is closest to aviation fuel. Here I could find something in the list which is called olefins. Here I found olefins right here. So olefins are actually a main component of aviation fuel and all fuels in general. So I found olefins right here and I immediately understood what I needed next. What I needed next was to find the material which was used to make the rubber tubing to transport the fuel from the fuel tanker to the aeroplane. Now that rubber tubing is usually made up of something which is called neoprene. That is what synthetic rubber tubing is made up of. So this olefins and this neoprene, when they are rubbed together, so the olefins will become positively charged and this neoprene will become negatively charged. I found neoprene right below olefins, just below PVC, just above PVC. And this is something which is really interesting. I found out that latex or natural rubber is also below olefins. So it did not matter which kind of tubing I was using, if I was using natural rubber tubing or if I was using synthetic rubber tubing. And moreover, all the different synthetic rubber tubing, such as you can see the list of synthetic rubber tubings right here. And these rubber tubings are actually below olefins. So no matter whichever rubber tubing you use, there's always going to be buildup of static charge. Now let us apply this concept and let's go back to the drawing board and show you and make you understand why I have shown you the clip of that aircraft refueling. Now that we are back on the drawing board, let us have a little short version of the Turboelectric series which I showed you earlier. I have written down a few of the materials which I have an interest in. I wanted to show you olefins, which is the main component of fuels such as diesel and petrol, and not just diesel and petrol, it is the main component of most liquid fuels in the sense like which is used in powering up cars, like in cars, in buses, in aircrafts, everything. Aircrafts, actually jet fuels in fact, have a mixture of naphtha kerosene, but they still contain olefins. So olefins are actually present in all these fuels in a pretty large number. And also I wanted to show you neoprene. Neoprene is present right here and olefins are present right here. Neoprene is present here. Neoprene is the synthetic rubber tubing. It is what rubber tubing is made up of. And I've also included other synthetic rubbers here. Since latex or natural rubber is not pretty easy, it's not pretty easy to make. So that is why industrialists and everyone, in fact, they tend to use synthetic rubber tubing. So as I had mentioned in the previous section, that this triboelectric series can be used to select materials which can be used to minimize static charging. So if I look at this table, I can see olefins here and I can see latex or natural rubber here. So in no way am I going to pass olefins through latex or natural rubber, because I had said in my previous video that the greater the distance between two materials in the triboelectric series, the greater is the magnitude of charge produced on either of them when they rub against one another. So that is why olefins and neoprene, that is the best combination that you can have. It's not the best, in fact, but it's better than most. So now let's see what happens when you are refueling an aircraft. When you are refueling an aircraft, the olefins which are present in aircraft fuel, they pass through the rubber tubing which is made up of neoprene. So when the olefins pass through from the tanker to the aeroplane for storage, so when they pass from the tanker to the aeroplane, then these olefins, the fuel rubs against the walls of this neoprene tubing. They rub against the walls of this tubing, and due to which this rubbing leads to a development of static charge. So since static charge gets developed, now if too much static charge is developed, then this charge can discharge. This charge might be discharged in the form of a spark. Now, if a spark occurs inside a tubings like this, which is connected to the aeroplane and the tanker, and it's connected to the rubber tubing through which the fuel is passing, and if a spark occurs in such a tubing, then it can lead to something pretty disastrous. The entire tubing is going to explode, and it's along with that the tanker and the aeroplane, both of them are going to get damaged. So that is what you need to keep in mind. So next time when you see at an airport, when you see a tanker refueling an airplane, this entire thing should play in your mind, because this is what science is. This is what you need to know. You need to understand the beauty of things which are happening around you. So I had explained the triboelectric series, and this is how you use the triboelectric series to solve everyday problems. If I had used latex rubber instead of neoprene, if this neoprene, I had not used neoprene and I had used latex rubber, which is natural rubber, then the development of static charge would have been greater, and there would have been a greater tendency for a spark to take place, and which would have led to something disastrous. So that's all for this video. Thank you very much.